Janie pushes the ball in an imbalanced force, which makes the ball move. The ball would then want to stay in motion, but will be stopped due to outside forces like a wall or friction caused when the ball is touching the ground. When the ball hits the ball bounces back because the wall is pushing back at the ball with a greater force. This is an example of Newton's first law because the first law stated that objects in motion will remain in the same velocity unless acted on by an unbalanced force, and the ball wanted to stay in motion, but it is stopped due to an imbalanced force, which is a wall. Because of this is an example of Newton's first law. Which pushes the tennis ball and a softball with equal amount of force. This tennis ball will have less accelerations than the softball because it has more mass. This is an example of Newton's second law because the second law states that an acceleration of an object will increase with more force and will decrease with more mass, and the tennis ball has the more mass than the softball. Therefore, it will have less accelerations. Because of this is an example of Newton's second law. Janie pushes a ball towards another ball. The first ball hits the second ball. The first ball then moves forwards and the second ball then moves backwards. The second ball moves forwards because of the momentum that the first ball transfers when it hits the second ball. At the same time, the first ball moves backwards because of the reaction force from the second ball. This is an example of Newton's third law because it states that every time an object exerts a force on another object, the second object will exert a force equal in size and opposite in direction back. On the first object, the second ball exerts a reaction force back on the first object, making it go backwards. Because of this is an example of Newton's third law. F equal ma. F is force, m is mass, a is accelerations. A pencil case has a mass of 0.04 kilograms. Lizzie pushes the pencil case in an acceleration of 2 meters per second square. What is the force that is needed to make a pencil case with a mass of 0.04 kilograms accelerate at 2 meters per second square? Force equal ma. Force equal 4 times 2. Force equal 8 newtons. The force of 8 newtons will make a pencil case with a mass of 0.04 kilograms accelerate at 2 meters per second square. Everything is blue.